Good day. Welcome to our session. On this session, I'll be doing Euclidean geometry. So I'll be focusing on the circle theorems. So on this session, our main focus will be on the circle. So I'll be showing you guys how each theorem works. And then on the video, I'll do examples from a past paper just to show you guys how to approach the theorems. And if you are new to our channel, please like, subscribe, and also comment and go through our playlist to see other content we've covered so far. So without wasting any time, I'm going to go straight to our lesson. So quickly, as a reminder, remember we've got triangles which we did in previous grades. So we've got 3 different type of triangles that we must remember from lower grades. We put the third one here. So we can have a triangle where all 3 different sides are not equal to each other. So we've got 3 different sides of that triangle not being equal to each other. Or you can have one where 2 sides are equal to each other, then this side is different. Or you can have one where all 3 sides are equal to each other. So we know that the one that all sides are not equal, we call it a scalene. The scalene triangle, where all 3 sides are not equal, we call that one a scalene triangle. And then where 2 sides are equal, is the isosceles triangle. So it's called an isosceles triangle. Call that an isosceles triangle. Sometimes we tend to use a symbol for a triangle like this. Especially when you're giving reasons, just go and put a triangle like that. That represents the triangle. Same thing, scalene, just put a triangle there that represents a triangle. Then the last one that we know is called the equilateral triangle, meaning all sides are equal. So it's equilateral. The name itself, it's giving us a hint that all sides are equilateral, equal to each other, meaning also all angles which are inside there must also be equal to each other. And then meaning if here we're having 60, then also that must be 60. That must be 60. Because all angles in this one must be equal to each other. And then on the second one, this angle here and this angle here, they are what we call base angles. Meaning if this one is 40, and then this one is 40, so this one also must be 40. Because the base angles must be equal to each other. So both of them must be 40 degrees, meaning the sum we know must be 180. So if it's 40, that's 8, meaning this one will be 100. So because the sum of a triangle must always be 180. So that's like a revision of triangles that you guys must know. But our focus today is on circle. So my main focus will be on the circle. So we know also from the circle that if we were to cut the circle into 2 equal halves, for example, just I draw a line there, then it's cutting my circle into 2 equal halves. We call this whole line a diameter, or just call it a D. So this whole line is called a diameter. And then we know that the half of the diameter, it's called a radius. So if I'm having my circle here, let's say that's my circle. So the half of the diameter is called a radius. So the half of diameter is called a radius, meaning for us to form a diameter, we always have 2 equal radius. So another part that you must know, for example, I can just come here and have this portion here. So this whole portion that I'm having here is called a segment. So this whole portion is called a segment. We call that a segment. Same thing. We can have this portion here. It can also be called a segment. So those 2 portions are called segments. So also we've got another portion, for example, that line that is a, we can call that an arc. So we call that an arc. That's like an arc that we're having there. And then now the whole part that you can have here, for example, this whole region from there to there, we can call that a circumference. So wherever it's meeting at the tip, it's called a circumference. So that's a circumference of a circle. And then also I've got another line. So another line that cuts our circle inside, we call that line a chord. That will be our chord. So those points are very important for you guys to know for the theorems, because the theorems will be revolving around those points. So without wasting any time, let's go straight to our theorems. So if you're having two, let's say I'm having from the center, let's say that's my center there. So this will be my radius. If I'm having my radius meeting this line, which is called a chord. So my radius is meeting the chord. So it's giving me two lines. I'm having that line there and also that line there. So wherever the perpendicular lines from the center bisect our chord, they always form 90 degrees. Meaning if this is angle A, for example, angle A must be 90 degrees because the perpendicular lines are bisecting my chord. So that line there, or that angle that will form there, will be 90 degrees. Same thing applies to the angle that will form there. It will also be 90 degrees. That will be the first theorem that you guys must know. The second one, if you're having a diameter, so just check, this will be our diameter. If a triangle is having a diameter, the angle that it will form at the circumference, that angle that will form there, will be 90 degrees. So in words, we can say the angle subtended at the circumference is a right angle triangle. By the word subtended, we mean made. So the angle that is subtended or made at the circumference is 90 degrees. Or in other words, some people always tend to say the angle on a semicircle is 90 degrees. So those are the two different ways you can say it. So don't be surprised if other teachers are saying it other way, but the two reasons will be those two. So again, we're having a circle. If now I'm having a center, let's say this is my center there, that's my center, and then again, remember this is circumference. So the angle that we form at the center is always 2 times the angle that we form at the circumference. So meaning if here we have 40 degrees, let's say our circumference angle is 40 degrees. Therefore, the one that we're forming at the center must be 80 degrees, because it's always 2 times the one that we form at the circumference, if they're on the same arc. That will be your theorem. And then let's quickly go to the bow tie one. So in this one, if, remember this will be the arc, if you've got angles which are forming at the circumference on the same arc, this arc and this arc here, if the angles are forming at the same arc, we call those angles must be equal to each other. So if those two angles, they're forming a circumference of the same arc, meaning they must be equal to each other. Meaning if this one is 20 degrees, that one must also be 20 degrees because they're on the same arc. Or you can say angles at the same segment are equal to each other. So same thing applies to this one. If here it's y, also this one will also be y. Meaning if it's 10, this one is 10, this one will also be 10 because they're on the same arc. Don't forget, this one is a triangle, meaning when we add this value that we have here and the value that we have here and the value that we have here, they must add up to 180, because they will not ask those type of questions if you've got two different angles. Then let's quickly go to our cyclic quad. So cyclic quad, it applies if your cyclic quad touches your circle at 4 different points. If it doesn't touch at 4 different points, cyclic quads won't apply. So in this theorem, the angles that you have, the angle that you have here, this angle that will form here will be the opposite angle of this one. So let's say here I'm having 40 degrees. The angle that you're going to form here will be 140. So the reason will be opposite angles of a cyclic quad are supplementary. Meaning, in other words, opposite angles of a cyclic quad, they must add up to 180. Meaning this angle here and that angle, when you add them, they must give us 180 on the cyclic quad theorem. Same thing applies. If here I'm having 30, the opposite angle of this one is this one. Meaning this one must be 150 because they are opposite angles in a cyclic quad. That will be our theorem. So the next one will be the extension one. Now if I'm having a line outside, so I'm having a line that is extending my cyclic quad now. So we call this an alternate angle. So the alternate angle that will form here, for example, the angle that will form here outside, the alternate angle, it will be equal with the angle that is forming then. So here if it's 10, this angle is 10. Also this one that is forming outside must be 10 in this theorem. But don't forget, the one that is opposite here, if here it's 70 for example, So here it's 10. So here you know it must be 170 because this whole thing must add up to 180. This line must add up to 180. So if I'm forming a 10 here will be 170. So this angle here and this one that I'm putting here and this one there, they are opposite of cyclic quads. So meaning they must add up to 180. But don't forget, the one that is forming outside and the one that is forming there, they must be equal to each other. So now we're having a line outside. We call this line a tangent line. So we call this one a tangent line. So wherever the tangent, wherever our radius meets our tangent line, it must always form 90 degrees. That's one is a quick one to remember. Wherever the radius meets the tangent, it must form a 90 degrees. So again, we're having our line outside, which is the tangent line. So on this theorem also, the alternate segments are equal to each other, meaning the segment or the angle that we're forming here will be equal to the angle that we're forming there. Same thing applies. If there is 20, that angle that is forming there must also be 20 because they are alternating segments there. So same thing applies. The angle that you form here, let's say we call this one y, will be equal to the angle that you form there because they are alternate segments. We call that a tan-chord theorem. So don't forget, the alternate segments must be equal to each other. And then also here we have got two tangent lines now. So our two different tangent lines now from the same, let's say from this point here and from this point here. So now our two tangent lines, they are meeting here at this point here. So the point where they're meeting here, they're meeting then. So the point where they're meeting, this is giving us two equal lines. So meaning if I were to also just join these 2 points together, let's say I just come and join these 2 points together here. So from here going upwards, let's say just go and join our two segments. You see now I'm forming a triangle, and then we know the type of triangle where two sides are opposite is the isosceles triangle. So that'll be forming an isosceles triangle, meaning our base angles must be equal to each other. So we're going to form that angle there, meaning also again, if I were to also, let's say I cut this into two equal halves. If you cut this into two equal halves, for example, we're having this angle, this triangle there, and this triangle there. So we must also know the triangle, the angle that forms there is equal to the angle that will form there. So those two angles are going to be equal to each other. And also the angle that forms there will form a 90 degrees. So we're going to form a 90 degrees there. Same thing will apply there at the top there. Will also form another 90 degrees. And also again, because we can form the vertical opposite angles, meaning the angle that you form there and the angle that you form there will also be equal to each other. So don't forget this angle. Let me just put different letters because I want it to look like it's the same as the other one. So here, for example, you just put y just to show that that angle there and that angle will be equal to each other. So if I'm having y there and I'm having y there, those two angles are going to be equal to each other. So that's how you can work with this theorem. Those two lines are equal to each other, but they're going to form a 90 degrees there. Also, a 90 degrees can form at the circumference because I'm having a diameter now. So the angle that will form at the circumference will be 90 degrees because it will be a semicircle in other words. So same thing applies to this one. But remember, it must be a diameter, meaning it must be in the center. So that will be your theorem that will form here for this one. And then these 2 points are equal to each other. These 2 points are equal to each other, same as this one. Then you just need to go and play around the triangles from there onwards. So also, just to that will be the last part. So that will be all your theorems that you must know. So same thing applies to this one before I forget with this one. So the angle that you form here and the angle that you form here also from grade 10, we call those vertical opposite angles, meaning those two angles must be equal to each other. If it's 20 there, this one must also be 20 because they are vertical opposite angles. Then the other ones will be 160. This will be 160, and the other one also will be 160 because they are vertical opposite angles. So that will be our theorems. So I hope this was helpful to you guys, and then please comment, and then we can do more examples in the next video. Thank you very much.